Yeah, so hello. Thanks for attending this presentation, which I have elaborated together with colleagues from Manchester. My name is Stefan Schulz. I work for the Medical University of Graz and also for software company Aberbis, which does text mining for clinical data. So, and it's about clinical narratives, clinical text, and I think we have heard a lot of it already, so I can really jump over the next couple of slides. This is not working here. Let me see. No, I won't take the mouse. Yeah, okay. So. It doesn't. Oh, maybe you should kill it and then start again. Okay, very good. So let's try again. We are a little bit behind schedule, so I will really jump very quickly over the next couple of slides because this is really something which has been mentioned several times in this conference. But again, the next slide doesn't come. Sorry. Oh, yeah, it's coming. I was perhaps not patient enough. Okay, so it's about clinical narratives, and I think it's well known that most information in health records is really locked in narratives, and that means narratives are in the local languages and even worse in the social acts. And the same way as all over the world, hospitals look very similar. Also, clinical language looks very similar, and clinical language is really let's say, optimized for expert-to-expert communication. So the important thing that natural language works is really that two health professionals are able to exchange messages. And so for human communication, it's not a problem that this language is very compact, sloppy, contextualized. So as we have seen also in Amanda's talk, these texts abound of acronyms. These acronyms often have different meanings, and you have to ask clinicians from a particular specialty to help you understand the acronym. And as little as is really a problem for human communication, it's a big hurdle for a big bottleneck for interoperability of health records when machines have to understand and to process clinical data. And so this is a desideratum. I think this has been formulated probably already 30 years ago. So the idea to make unstructured health record data interoperable using international standards, using ontologies, using vocabularies, using information models. And the new thing here, what I'm proposing and what I'm arguing for in this talk is really that this effort of making unstructured health record data interoperable be rooted in applied ontology principles. Yeah, we have those international standards like SNOMED CT, like HL7 FHIR. At least SNOMED, I think, with a certain tolerance, we can call an ontology. But the important thing is that it is standardized. It has a huge user community, and therefore it covers I would say, most of content of electronic health record. And so what we are hoping that NLP technology is able to, for instance, to identify certain words and sequences of words and then assign SNOMED concepts. But I think it's also clear that this is not enough, because just picking out words and terms and then mapping them to standardized codes is not a sufficient representation of the content of a clinical document. Maybe it's sufficient for indexing, for document retrieval, but not for a richer representation of the content. And what we should think about is what could be not only a kind of standardization of clinical terms, but what could be a kind of canonical representation of this content of a document. And so one kind of representation, which you can say that it's older, it's new, but the term knowledge graph is quite fashionable. But of course, it's something like an instantiated ontology. And that means that the target representation, which we yield by interpreting heterogeneous textual data with NLP, that this target representation should resemble a kind of graph-like structure. And such a graph-like structure could then ideally be aggregated by many other graphs and then queried by a large range of use cases. And normally we distinguish between primary use cases and secondary use cases. For instance, a primary use case could be question answering or document summarization. So imagine you have such a knowledge graph extracted out of a bunch of clinical documents, and then you can just query it. And the way we know it a little bit now with large language models. And even better, you could use this for input data for decision support. But you could also think about building a huge collection of such knowledge graphs in order to do research over cohorts of patients, for instance, retrospective research or patient recruiting for clinical trials. And of course, such compilation of many patient histories would also be an interesting input for the training of predictive models and decision support systems, etc. Another aspect is, once you have such a knowledge graph at a patient level, you could also do what is called knowledge curation. That means that with the intermediation of certain user-friendly interfaces, that so-called health data curators or even trained patients could curate their own health data. Yeah, for instance, identifying gaps, identifying errors, putting the association of diagnosis and dates right. Yeah, correcting something like, for instance, if the knowledge graph tells you that you had 6 femur fractures because it was mentioned in 6 different documents, that all of these refer to only one fracture, for instance. So this is, yeah, the potential of knowledge graphs. And perhaps another aspect is also that, because later on I will really focus on these 2 standards, SNOMED CT and HL7 FHIR. And these 2 standards stand for, on one hand, let's say the model of meaning, the ontology, the meaning of clinical terms, and on the other hand, the models of use. That means the contextualization of instances of ontology concepts. And this difference between models of meaning and models of use, or these two expressions date back to a paper by enriched, written, I think, 15 years ago. Yeah, coming back to natural language processing as the key technology to build such knowledge graphs, to create an output which then can be represented as a knowledge graph. And I won't say much about NLP methods because this has been repeatedly also mentioned in other talks. But it's important to distinguish between the classical pipelines, is sequential processing of different aspects of human language, which then end up in an output which ideally normalizes terms by codes and creates relation between these codes. And these classical pipelines, they depend heavily on rules and lexicons. And as everybody knows, these are getting not really substituted, but paralleled and partly outsmarted perhaps by so-called end-to-end approaches, in which single architecture directly maps input text to the desired output. And this is also what we just heard in the previous talk about deep learning approaches like BERT, like BioBERT, and so on. Yeah, but the use of this does not come for free. And also we have heard about annotation efforts. And this is really a very important fact, that those end-to-end deep learning approaches, they are data hungry. They need to be trained by data. And in order to normalize clinical narratives, you need to annotate clinical narratives. That means you have to invest a lot of effort in order to add, let's say, concept annotations and relation annotations to training texts. Yeah, and this can then be, these texts can then be used on the one hand for training language models and for fine-tuning language models, but on the other hand, they are also very necessary in order to benchmark NLP systems. But document annotation, especially if it has to fulfill these goals, is really not trivial because it requires domain expertise, extensive training of human annotators. The annotators need to be motivated to do this, and there are lots of problems like the variability between annotators, even well-trained annotators. If they do the same annotation task in parallel, often they come up with different results. And this is not very good if we want to create a gold standard. And it really requires a lot of time. And this graph shows that you have a certain learning curve up to really to get productive. You have to do guideline developing, you have to test the guidelines, you have to update guidelines, and then you have to train the annotators on the guideline, you have to train the annotators on tools, and then you find out that they make certain errors or they misinterpret the guideline, and you have to do it iteratively and refine the guideline, etc., etc. So this is really not to be underestimated, but it's extremely important. Yeah, so we need good tooling, we need repeated training sessions, we need adjudication between the results of annotators, and we need periodic quality checks. And the measure to do this is inter-annotator agreement. And of course, also in most of the annotations, it's via adjudication, but it means also that the annotators need to be able to communicate, to discuss, so it also requires good communication channels. But the most important thing I would say here, and this is the topic of the reminder of this talk, is that we need rigorous annotation guidelines. And these rigorous annotation guidelines should be based on clinical standards and ontological principles. So, and what we have found out, the best annotators are medical students. This is quite interesting, because I also know from many annotation experiments or efforts with clinical doctors, which were just disappointing, but it has to do with the following. The medical students, they still have to do a lot of exams, and nothing is better to refresh the knowledge than doing annotation. And they learn this, they are aware of this, that they are paid for this, and as a side effect, they refresh constantly their medical knowledge. And read clinical documents, which is also interesting for them, just to broaden their the clinical knowledge. So they need annotation guidelines, they need annotation tools, they need also access to the annotation vocabulary. Here, just what we are using, the annotation guideline, I'm gonna explain in a minute, but also the annotation tool, which is an inception annotation tool, and the SNOMED CT browser. You can also, for instance, the inception tool, you can also import terminologies, but so far the students really, they are so used to that SNOMED browser that they prefer copying and pasting the labels from the browser into the annotation tool. So now looking closer at the annotation guideline. And this annotation guideline really, it's a document with perhaps 35 pages, but rarely ever such a document was so often revised and rewritten. And creating this document, getting constant feedback from test annotators, this document has established a set of principles. And perhaps I should also mention that we had already drafted large parts of this document, and then we had a meeting with the NLP group in Manchester, and we were happy to find out that our ideas were really converging. And this was the reason why also they gave us a lot of input into that document, and they co-authored this paper, and also together we tried to formulate such annotation principles. So the annotation principles we pursue is that we do semantic annotation only. So no POS annotation, no syntactic relations, nothing, only semantic annotation, and only at two levels. The one level are the text bands, so-called entities, and they are annotated with codes or with literals, for instance, dates or numbers. And then they are linked by binary relations with user-friendly predicates. So it's very important if we really use standards like SNOMED and FHIR, and we cannot confront the annotators with the complicated slots in FHIR and the dozens of different object properties in SNOMED. So it is very important that we simplify the relation annotation level. Yeah, then annotation vocabularies should be linked to ontology-based standards, like those here. They should be multilingual, well-curated, free, or free for research, which, for instance, SNOMED is free for research. Wherever you live, you can get a research license. Yeah, and they should be compositional. Yeah, they should allow cross-coordination. I will show you one example, which I think makes it very clear. Yeah, and then the annotation vocabulary is what determines the annotation spans. Often annotation tasks started with a automated named entity recognition step, which already determined the span. We are not proposing this. We are really let the vocabulary determine the span. Yeah, then close to text annotation, I'm gonna show you an example for that. Yeah, and then specific annotation principles regarding to SNOMED and FHIR. I won't go very deeply into that, but we distinguish between so-called core hierarchies, which are a high proportion of fully defined concepts, and supportive hierarchies, which are normally primitive concepts like substance, organism, body structure, and so on. We also use HL7 FHIR value sets, or HL7 value sets proposed by FHIR, but mapped to SNOMED concepts, so that annotators do not have to choose between HL7 value sets and SNOMED. Yeah, and ideally, the core concept should always be, well, the core concepts, even as standalone, for instance, something which is a very specific concept, like, for instance, 3-degree burn of the lateral side of the left index finger or something like that. Maybe there is a concept for that, and then you are happy to have it. But the supportive concepts, they should always be grounded into or should be related to core concept. Because if you have just something like, let's say, index finger and annotated with the SNOMED code for index finger, not related to anything, it is useless. Yeah. Well, this is a bit more about this relation annotation vocabulary based on both SNOMED and FHIR, because there is a problem. We have the gray area between SNOMED and FHIR. It was mentioned in one of the previous talks. That is really a problem, that there are, for instance, how to relate negation or family history to a SNOMED concept. You can do this with SNOMED only, or perhaps better, you should use FHIR for this, and you should embed the codes in FHIR resource instances. Yeah, and here the goal, what we pursue, is this green column, that we define a simple annotation vocabulary, which we give to the annotators. The annotators have also this table where they see what's the domain and the range of this relation, and then the right thing, this is something which happens behind the scenes. This is then used when we do what I would call knowledge graph enrichment. So here just some examples. For instance, here the so-called two-level annotations, text spans with codes or literals. Here one case like open fracture of left femur, and the patient had a heart attack on December 3rd. You see in the upper example a concept to another concept, in the lower a concept to a literal, and you have this annotation, this relation annotations with a prefix anno, which is really tailored to what the users can understand and easily process. Then what I already called deep annotation, so that you really should, if you find a corresponding concept for unilateral conjunctivitis, right, you should use this and not something more higher level. There are or have been in the past annotation challenges also where it was just something like that. Yeah, disorder. Yeah, this is not very useful, because what we want to get out, we want to train models, and also use concept mappers from, let's say, more pipeline-based NLP systems, in order to get the best result possible. Yeah. Then we have these flexible annotation spans, and we follow the longest match principle. And the spans, the size of the span is determined by the annotation vocabulary, and preference is given to longest match. That means in most cases, or in many cases, pre-coordinated concepts. For instance, here the femur exhibited an open fracture. And fortunately, there is something like open fracture of femur in SNOMED CT. If we have something like the thumb had an exposed fracture, unfortunately, we don't find it. So we do the best we can. We have the thumb structure and exposed fracture, and then we need to relate it. So that, in the background, the upper example, open fracture of femur, due to its DL representation, its owl representation, also is equivalent to an expression with a relation, or with several relation. Then another principle, close to text. The annotators should not lose productivity by discussing whether, for instance, here headache following brain concussion, this is after or due to. No, it's written following, so it's a temporal relation. And the interpretation, of course, this should probably be interpreted as due to, but perhaps the patient had this headache anyway. But this is not up to the annotators to decide, yeah? And to lose time discussing these things. When it's a temporal relation, then they annotate with after. When it's a causal relation, then they annotate with due to. And then, of course, there are other things, interesting things from a linguistic point of view. For instance, nominal anaphora, that you have what is called co-reference, because here a sarcoma was diagnosed. The tumor, of course, tumor and sarcoma point to the same entity. So again, this idea of canonical representation. So the annotation guideline is being crafted in order to get as much guidance as possible to really lead the annotators to or keep them on the right path, so that really ideally two annotators independently end up with the same result, which is yet to be measured. This is what we plan to have also experiments to measure inter-annotator agreement parameters. But a final word to what comes what comes after these annotations. Yeah? In the text, we have words, we have phrases, we have numeric expressions. Then in the annotations, we have codes for classes, we have these annotation predicates, we have literals. But then in the knowledge graph, there is an additional step, which I'm showing now. For instance, here we have the text, suspected, 3 different snippets. We have suspected breast cancer, we have mother breast cancer, we have diagnosis breast cancer. And I hope you can see it. Yeah, here. This means here verification status. Yeah, this is one of the relations they can use, and this is here in family. So you see, it's very straightforward. And here there's nothing because diagnosis breast cancer. So, and we see here at the ontology level the terms used for the entities. And the interesting thing is here, which requires a certain post-processing. That means we want to end up with a FHIR information model in which these codes are contextualized. And so we have, for instance, here, well, can I think it's difficult to point. I can point with the mouse. Yeah, in this case, neoplasm of breast is just kept as a type. It's not instantiated because we don't know whether it exists. But we have here as a instance of the FHIR resource condition, which is diagnostic statement, and then according or triggered by this anno verification status, according to this table I had shown previously, these 2 slots are filled. The verification status slot is filled with suspected, and the clinical condition slot is filled with this concept. If we have here another thing like mother breast cancer, then in family triggers the instantiation of another FHIR resource. That means another information template called FHIR family member history. By the way, all those things are IO information content entities. Yeah, and this family history statement here, the instance of this family history statement is then linked to mother, which fills a certain slot in this model, and here the condition of the mother also in a certain slot. And then here we have the simplest case, and which has really a clear truth value. That means it's not suspected, it's not negated, and then we really instantiate it here. So it's really this diagnostic statement instance from the FHIR condition resource is related to this instance of neoplasm of breast that can be important then in order to find or to link instances or find co-references that it's really referred to the same instance. Well, there are some other things here, like for instance the date, which is of course this is from other parts of the text, but you can link to the date, and of course you have to link to the patient. Yeah, so I'm summing up. Annotated corpora are essential for training and also for benchmarking NLP tools, and NLP tools means more and more AI-driven or deep learning-driven tools. And nevertheless, semantic resources and ontology-based standards are crucial when you really want to, well, get at least close to some kind of canonical ontology-based knowledge graph representation, where the ontologies bring you the definitions and axioms, the terminologies, the labels and the synonyms, and the information models, let's say, are the yeah, I would say the templates which contain all these other codes and references. We should not underestimate the difficulty of clinical free text annotation. You are only successful if you have motivated annotators and if you have enough time to train them. The annotation task can be facilitated, and we are doing this using a standard NLP tool by pre-annotating, so that they have not to start from zero. They find many pre-annotations already. They have to check them. They have sometimes to correct them. They have to fill gaps. They have to link them. And what we also have found out is really we need intuitive, not too big set of handy predicates that map to more complex graph structures in the background, but the annotators definitely should not learn the intricacies of FHIR information models, and also not the intricacy of SNOMED CT post-coordination. We have tried this, but this is just too complicated, and if we just give them an easier set of relations and just keep the processing as a, let's say, downstream process. So for creating this kind of knowledge graph I have just shown you, this turned out to be much better. Yeah, and the adherence to detailed guideline principles is really a long journey, but it's indispensable for high agreement between annotators in order to produce really clinical, canonical clinical content graph representations. So this here, my contact, the acknowledgement to funding from the EU, from Germany, and also from the UK, and you have here also a link to the annotation guideline, and I'm very happy if you visit this annotation guideline and ask questions, provide suggestions, and so on. Thank you very much.